Hello and welcome to the topic of the Earth. In this lesson, we're going to be talking about how are Earth systems connected. Specifically, what we're going to learn in this lesson is 1. How does the water cycle show interactions of Earth systems? 2. How does weather show interactions of Earth systems? And 3. How does the rock cycle show interaction of Earth systems? So let's start with some key vocabulary. The first word is water cycle. Now, water cycle is the series of natural processes by which water continually moves throughout the hydrosphere. So you can see an example here where it's constantly moving. Now remember, cycle means circle. Evaporation is the process of a liquid changing into a gas at the surface of the liquid. So evaporation is at the surface of the liquid when it turns into a gas and goes up into the atmosphere. Transpiration. Transpiration is the process in which plants release water vapor through their leaves into the atmosphere. Condensation. Condensation is the process by which a gas changes to a liquid. And you usually see this when you have a piece of glass and the temperatures are different on each side. Like if you're inside and you have air conditioning and it's really cold and it feels good, but it's really hot outside, right? Then you'll get that little layer of liquid on the window. Same thing when you have a glass of water. It's very cold inside the glass, but it's warmer outside, so you get that water on the outside of your glass, or that gets at the bottom on the ring. Precipitation. Precipitation is when water, either liquid or solid, all right, rain or snow, falls from the atmosphere. We call that precipitation. So it's when water that's either liquid, which we call rain, or solid, which we call snow. Weather is the atmospheric conditions along with short-term changes, short-term in time, of a certain place at a certain time. So the weather would be Friday, April 4th in Bangkok, Thailand. That's the weather. Climate is the long-term average weather conditions that occur in a particular region. So the climate would be the rainy season in Southeast Asia. A rock cycle is a series of processes that changes one type of rock into another type of rock. And again, it's a cycle. All right? So we call that the rock cycle. You also have what they call uplift. Uplift is the process that moves large bodies of Earth's materials to higher elevations. You know, sometimes it's squeezing the Earth's surface, and so what happens is it starts to go up, and it uplifts, and that's how you create mountains. So let's go ahead and begin your lesson. So we said the water cycle is the continuing movement of water on, above, or below the Earth's surface. Now the sun is what provides the energy that drives this cycle and moves water from one place to another place to another place. And understand that water can change state to a gas, to a solid, then back again to a liquid. And in the water cycle, it can have different states as the sun provides the energy that moves it from one place to the next. Thermal energy from the sun is released or absorbed when water changes state. So when we say thermal energy is absorbed, that's evaporation. When it is released, it is called condensation. So as we release thermal energy, you'll get condensation. As we absorb thermal energy, you will get water vapor. All right? That's how these various things start. So evaporation is the process where water changes into gas. All right? Transpiration is when plants release water vapor out of their leaves into the air. All right? Now understand, this is not all about heat on the plant. Sometimes in a plant, it's a process almost like breathing. So it's called cellular respiration. So here's a nice big picture of the water cycle, right? So you have precipitation, where water's falling down and hitting the ground, right? And then you have runoff, where it's from the ground or from the river out into a body like a lake or the ocean, etc. And then the sun is shining down on that, right? And that's making it evaporate. As it heats up, the water's going back up into the air. And then what happens is condensation. As it starts to get higher in the atmosphere, it cools down. And then what happens is it gathers together as it gets cooler into clouds, right? And then those clouds can move, right, and transport the water. And then all of a sudden it starts precipitation, right? Again, it starts raining again or snowing again. This is snow and this is rain. So it all depends on temperature. And then when that water hits the ground, some of it will run off into a large body like we saw here, and some of it will go down into the ground, right? And that'll be groundwater. And then it runs off again, then it gets evaporated, then it condenses, then it transports, then precipitation, then runoff, and back. So you can see it just goes around and around and around. That's what we call the water cycle. The process by which gas changes to a liquid, again, is called condensation. All right? So it changes from a gas to a liquid. The moisture that falls from clouds to the Earth's surface is called precipitation. So you have condensation and precipitation. Now, key concept check. How do Earth systems interact in the water cycle? Well, water continually to move through the hydrosphere and the atmosphere and the geosphere and the biosphere when we drink water and then we sweat. So that is the water cycle, and that's how Earth systems interact with it. So it moves through these different spheres within Earth systems. Now weather, when we talk about weather or changes in the atmosphere, it's about what is the atmosphere at a specific time and a specific place. What is the weather in Bangkok on Friday, May 4th? What is the weather in England on Tuesday? So weather is influenced by conditions both in the geosphere, on the surface of the Earth, and the hydrosphere, what's going on in the water, etc. All these different spheres impact and affect the weather in a specific time, in a specific place. So we describe weather using different, I would say, quantitative data, which is from another lesson. So we use numbers to measure. Some of the things we measure are air temperature, air pressure, wind speed, what direction is the wind going, how much humidity or water vapor is in the air. And all of this together will describe our weather. So key concept check. How does weather show interactions of Earth's systems? All right. Weather is influenced by conditions in the geosphere and the hydrosphere. So basically, the Earth and the water, the land and the water interact, or their conditions affect the weather in the atmosphere. So when we talk about climate, climate is the average weather pattern for a region over a long period of time. All right? So it's not short, it's not a specific location, it's kind of a bigger area, and we look at it over a longer time. And we look at, for example, it may be drought, right? Or it may be windy, or it may be cold. So climate is about bigger patterns. So what is the climate in Southeast Asia, for example, during the rainy season? Now, as wind blows over the ocean, right, it creates what we call surface currents. And those surface currents will move thermal energy around the planet. It will move cold and hot water around, which can also change the temperature of the water. So, it may be that the wind blows the cold Atlantic water in towards the coast, and then when it gets towards land, it warms up, and then that makes it go back out. And so when the water heats up, it rises to the surface. When it cools down, it goes down deep. All right? But this causes these cycles within the ocean, or the ocean currents. We get surface currents. Now, mountains can also affect weather. They can affect the amount of precipitation an area receives. Like, for example, you got a lot of water evaporating from the ocean, right? And then the winds from the ocean pushes that inward and up. The mountain makes it go up, and so it starts to cool. And when it cools, it condenses, right? So now you have all this cool air that condenses into a cloud, and it starts to precipitate, or rain, or even snow. And then it continues, so all the rain's out, and it continues to push up over the mountain. And then you get what's something on the other side of the mountain, you get something called the Rainshadow. Because the mountain pushed all the air high up, and it cooled very quickly, and then it rained. And there was nothing left to go over the mountain to rain on the other side. So the other side of the mountain becomes the Rainshadow. It gets less water. You also have something called the rock cycle. And the rock cycle is a bunch of processes that transport and change rocks into different forms. As it moves through the rock cycle, it can change from igneous rock to metamorphic rock to sedimentary rock. All right? So depending on what happens. So igneous rock that melts turns into magma. And then when it cools, it turns back into igneous rock. Igneous rock that erodes or breaks down turns into sediment, which then, when pushed together, forms sedimentary rock. Now, uplift is the process that moves large bodies of earth materials to higher elevations. So you might have two plates that are pushing together, right? And it just pushes the earth's surface up. This uplift. So as this one is moving this way, and this one is moving this way, it forces everything to go up. And then as it gets up, it gets this weather, and then you get erosion, and all the little pieces go running down, and they deposit again as sediment. And then that sediment is pushed down, where it then starts the rock cycle over again. So you get another example would be magma, which is underneath the ground, and then it hits the surface as lava, right? And then it cools into igneous rock, and then it erodes because of the rain and the wind, etc. And it transports all these little rocks, etc., down into the water, which then settle at the bottom of the ocean. And then they get pushed down into the earth as more and more come down, right? And then it starts making heat and pressure. So that metamorphic rock was sedimentary, then it becomes sedimentary rock, but then it's pushed deeper into the earth. And then there's more force on it, pushing it. And then it gets hotter. So that sedimentary rock all of a sudden fuses together into metamorphic rock. And then the metamorphic rock then cycles in, it gets deeper until finally it melts and maybe it turns into magma. That then goes back up and it starts it all over again. Now, remember that once that rock hits the Earth's surface, it can be exposed to the atmosphere, the hydrosphere, and the biosphere, and it starts to break down. It starts to weather because of the wind, the sun, the rain, the snow. All of it affects the rocks. It breaks the rocks apart into sediment. And this process that we do this is called weathering. All these winds and frozen water and rain and snow, etc., just break apart the rock and we say, oh, that's weathering. Now, when these sediments flow down into rivers or flow down into the mountains or wherever they're going, once they settle and deposit, once they stop moving, we say they've deposited. All right? And once they've deposited, then they start to get pushed together. Not like metamorphic rock, but they start to push together and they form sedimentary rocks. All right? Or layers of sediment that you will see when you dig through. Now, as one layer of sediment, and then another layer of sediment, then another layer of sediment, and another layer of sediment, and they all start piling on each other, right? One after the other, and it will do two things. It will compaction and cementation. Compaction means you have these little itty-bitty grains, right? Like that. And they just start pushing together. So it looks something like this, right? And then they start pushing together these grains. So they're all loosely formed. And that's compaction, right? But then cementation has more layers. Now these grains start really getting pushed together. So they become fused into one little rock because there's so much pressure. All right? And maybe there's a little bit of other materials in the middle of the little grains of rock to kind of hold it together. Now, once too many layers get going on, right, and it pushes them farther and farther down the Earth's surface, that's when metamorphic hits. Because it gets hotter and hotter and hotter, and the pressure gets more and more until it goes from that cementation to metamorphic. It just fuses together in one big solid form. So a key concept check: how do Earth systems interact in the rock cycle? And again, we said the geosphere impacts the rock cycle through uplift, deposition, compaction, and cementation. All right? That is the sedimentary interaction. Uplift, weathering, deposition, compaction, cementation. And then when we get high temperatures and pressure, as more and more of those layers build up, that becomes metamorphic. All right? Now, the atmosphere and the hydrosphere, those impact rock through weathering, through rain and wind, etc. That's how those systems. So Earth systems, atmosphere and hydrosphere, do weathering, and the geosphere impacts the rock cycle. So in summary, the water cycle means water continually moves through the hydrosphere, the atmosphere, the geosphere, and the biosphere. And weathering and climate are influenced by interactions between the atmosphere and other Earth systems. And in the rock cycle, rocks continually change from one form of rock to another form. So there's your lesson on how are Earth's systems connected. We hope you enjoyed the lesson, and we'll see you in the next one. Thank you.